Welcome to the Check Your Understanding for 9.2b, the four-step process for doing a hypothesis test for a proportion. According to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A news report claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees finds that 68 answer yes when asked. Does work stress have a negative effect on your personal life? Do these data provide convincing evidence at the alpha equals 0.10 significance level that the proportion of all employees in this chain who say yes differs from 0.75? So notice how, the prompt, it just wants you to test whether the proportion is really just different than 75%. Even though we've already read what their statistic is, which is 68%, even though that's less, we're not going to make this that we're testing P is less than 0.75 because it says investigate whether it's just different. So don't base your alternative hypothesis based on the statistic, base it on the question. So be careful about that. So let's look at our state. So in your state, you're going to define the parameter. So this is a question about a proportion. P is the true proportion of employees who say yes. Our null hypothesis is that claim that the proportion is 0.75. The alternate, that it's not 0.75. So if we get anything unusually above 0.75 or anything unusually below, that would lead us to reject the null hypothesis. Your statistic, your p hat, that was collected from data is 0.68, and we're going to do this test at the 10% significance level, and that's alpha. Okay, what's the name? This is a one sample. We only have one sample of 100. It's a z-test, doing a significance test for that proportion P. And then you go through and check your conditions. So you need to check the random condition. It was a random sample of 100 employees. That way we can generalize to all of their employees. The 10% condition, so we have sufficient independent because we're sampling without replacement. 100 is less than or equal to 1/10 all employees at that large restaurant chain, or maybe they don't tell us that, but we'll assume that. I mean, it's a restaurant chain, so they have a lot of employees. And then you check that the sampling distribution of the statistic is approximately normal. So because this is about proportions, we check the large counts condition. And notice I'm using P, not P hat. I would expect in a world where the null hypothesis is true to get at least 75 successes and 25 failures. 75 employees to say yes and 25 to say no. So we're good to go and use that sampling distribution to create our test statistic and stuff. All right, now time to execute. Oh, I made it yellow. Execute. So general formula for the test statistic: observation minus mean divided by standard deviation. So that's going to be the statistic, p hat, minus what was P in that null hypothesis, divided by standard deviation. So p hat minus P, that's the standard deviation of p hats. And we get, we're working down this left-hand side. We get the test statistic of negative 1.617, which is telling us our observation was negative 1.617, standard deviations below what was expected. We would have expected 0.75. Now, check out this picture on the right here, top right. So this is the sampling distribution of p hats. From where the population proportion is 0.75 because we assume the null hypothesis is true. We got the labels, but it's two-sided. So as far as calculating the p-value, we want to find the probability of getting a value that's negative 1.61 standard deviations below the mean or above the mean, if anything was extreme on either side. So if you calculate this green little probability here, what's the probability that I would get a value 6.68 or less? It's 0.0518, and maybe you would have rejected the null, but if we also got a value up here, so you need to double that. Our probability of getting something as far away from the mean in either direction as 0.68 is 0.1036. So when it's two-tailed, whenever your alternative hypothesis is just not equal, you have to basically calculate that p-value as you normally would, but then double it. And in your picture, you need to show your two sides. Here is our conclusion. So you compare your p-value to your alpha level, decide to reject or fail to reject, and then talk about what kind of evidence you have or what you don't. So here's the conclusion. Because our p-value of 0.1036 is greater than the significance level alpha of 0.10, we fail to reject the null hypothesis, H sub 0. We do not have convincing evidence that the proportion of restaurant employees who feel work stress affects their personal lives is not 0.75. So 0.68 was not unusual enough for us to reject that null. Make sure you have context in your answer, that you bring it back to talking about restaurant employees. Now, relating it to confidence intervals, a 90% confidence interval for the restaurant worker data was also created and found to be from 0.60 to 0.75. Explain how the confidence interval is consistent with but gives more information than the test. Now remember, in a confidence interval, these are all plausible values. Plausible, and notice how 0.75 is one of your plausible values. So why would we conclude, reject the idea that the true proportion is 0.75 when this confidence interval says 0.75 is possible and kind of likely? So this null value of p.75 is included, so it's plausible and consistent with the test. And the more information, you're asking okay, what more information does it give you? Well, there's other plausible values. So remember, a significance test, you're making kind of a decision about a claim, or a confidence interval, you're estimating it.